Good afternoon. Can everybody hear me okay? Sounds like it. So my name is Michael Jennings. I'm the lead HPC sysadmin for the High Performance Computing Services Group at LBNL. Not to be confused with NERSC. The National Energy Research Scientific Computing Center is a national user facility. My group specifically caters to Berkeley Lab researchers and provides them with cluster management services as well as user support services, answering questions, helping them get their programs working, and so forth. We also have a contract with UC Berkeley, so several of us, myself included, are essentially employees of the University of California, Berkeley, providing campus with research computing services, essentially doing much the same type of thing there that we do up on the hill at Berkeley Lab. So 2 years ago, I gave a talk introducing the Node Health Check project. I don't want to spend too much time going over the stuff that I talked about then. Fortunately, as with this year, insideHPC was kind enough to record that talk. So if you missed it the first time around, at the end I will have a URL for you so you can go back and pick up what you might have missed. But most of this is going to be continuation of that. Steve and his team use NHC and asked me to provide you guys with an update of what's been going on the past couple of years and where we're going in the future. But for those who might not be familiar, the Node Health Check project is an extensible framework for measuring and reporting on the concept of node health. Now, what exactly that means varies from system to system and from institution to institution. So the goal of NHC was to provide a flexible and extensible framework so that each administrator and each site could quantify what health was to them in a way that was easy to manage, could be centrally managed, and could evolve and change over time. It was originally written specifically to work with Torque, but has since evolved to work with Slurm. It works with SGE, UGE, OGS, and all the various products that have resulted from the implosion of Sun. It works with Platform LSF and pretty much any other workload management system. It has even evolved to be useful outside of the context of a cluster. We ourselves use it for monitoring standalone servers as well. There are a number of checks that are already built into it out of the box, and it's very easy for you to write your own. A check is simply a bash function, or really anything that bash can do. NHC is implemented in 100% pure bash. It's all shell, makes it very easy to learn and pick up, and it's written in an extremely efficient manner. If you look at most of your shell scripts that you're used to seeing, you'll see a lot of grep and sed and awk and all sorts of subcommands that get shelled out to. I have gone to great and sometimes pathological lengths to avoid having to do all of that. Anytime you execute a subprogram, you incur a certain amount of risk of commands not being present, things hanging, things going wrong. So NHC is very determined to do that as little as possible, and it does a really good job of it too. You'll see a lot of variable manipulations and all sorts of fun stuff that you've probably never ever seen bash do in your life. But it's extremely efficient. And in addition to NHC itself, it comes with some tools out of the box that make it even more useful. There's a wrapper script that allows you to run it as often as you want, but only report, i.e. harass you, on a certain interval. For example, you can run it every 5 minutes, but only have it bug you every 6 hours, or something like that. You can run it in a loop inside a terminal. And there is a tool called GenConf, which will actually generate a working starter configuration for you that you can then proceed from. If you've never used it before, if you're new to NHC, you run that, it gives you something to work from. So I went over all of these pretty much already. 45 checks built in. We're always getting more and more contributions. I've got a pull request sitting out there with yet another new check that I need to deal with. And we always welcome more contributions from the community. So what's new? Well, when I did the talk 2 years ago, the project was named Warewulf Node Health Check. Warewulf is a project at Berkeley Lab that is a cluster management toolkit. It does provisioning and management of nodes within a cluster. There was some confusion with users who would see Warewulf Node Health Check and think that they had to manage their clusters with Warewulf in order to make use of the Node Health Check, which was not at all the case. And so for that reason, to help clear that up, and for some other reasons, we decided to go ahead and split off the NHC project and have it stand on its own. So I talked to the attorneys at the lab and did lots of paperwork, and voila, we have Berkeley Lab Node Health Check. Same project, same developers, just a different name. In addition to that, where previously Warewulf was developed via Subversion on a private Subversion server at the lab, NHC development has now moved over to GitHub. This was an extremely popular move and has made it a lot easier for users in the community who use NHC to contribute back. So if you already have a GitHub account, you're more than welcome to go fork the project and write your own checks and submit pull requests for those. In addition to GitHub, there's a parallel tree on Bitbucket. The lab has a Bitbucket contract, and Bitbucket has a few advantages in terms of private repositories, so I have an account on both. And I figured, what the hell, may as well. So I maintain both trees, I keep them in sync. If you prefer to work with Bitbucket, if you're in the same position and your company has a contract with Bitbucket and it's easier for you to go that route, you're more than welcome to. Pull requests work just the same way on Bitbucket as they do on GitHub. If you like the issue tracker on GitHub, or on Bitbucket for that matter, we take issues as well. You can send email to the list or use the issue tracker. Both work equally well. For real-time communications, we've always used IRC, and IRC is still available for those who prefer that, but a lot of modern developers, especially the GitHub crowd, like something a little bit more up-to-date, as do I. So in addition to moving to GitHub, I added a couple new options for talking to the developers, i.e. me, and interacting in a real-time basis. The ever-popular Slack, if you have not used Slack, you're missing out. It's an incredible collaboration tool for teams. If you have a team of developers or administrators or anybody with a mobile phone, you owe it to yourself to check out Slack. It's pretty awesome. And it's got API integrations with just about every development technology created in the last 10 years that you've ever heard of. Definitely worth your while to check out. And of course, Yes.
A question, have you tried Rocket Chat?
Have I tried
Rocket Chat?
Rocket Shed?
It's an open source variant of Slack.
No, I had never heard of it. I'll check it out. We do actually have instances of River, but I don't see enough of a big difference to make it worth my while. But if people disagree with me, I'm open to being convinced. But I have not heard of that one. I'll have to check it out. For those who use GitHub, it's very easy to make the leap from GitHub over to Gitter. So we also offer real-time chat on Gitter. And as every project needs to have a mailing list or two, we have mailing lists or two. For users, we have NHC at lbl.gov or under the LBL instance of Google Groups. Previously, you had to subscribe to the mailing list to be able to post to it. I had about 5 different people try to send email to it and get the rejection message saying that either this doesn't exist or you don't have permissions to post. Confused the hell out of them, got complaints. Long story short, I fixed that. So you don't have to be subscribed to the list to post anymore, but if you're not a subscriber, your message is going to get held until I have a chance to let it through. For the developer list, though, you have to subscribe. Easiest way to subscribe, send email to those addresses with +subscribe. So NHC +subscribe at lbl.gov. That'll subscribe you to the list. So all of these features, all of these changes took place all at the same time. And as if all of that wasn't enough, I decided to throw a new release on top of everything. So the latest release is 1.4.2, and there are a number of interesting new features that I wanted to talk about briefly. So for those who've used it, you'll remember that Node Health Check has a concept of a match string. The main place where that's used is every config file line starts off with a match string that determines which nodes a particular check is going to run on. So you can have a single config file that works across your entire cluster, and each check line will only run on the nodes where that match string matches the host name of that node. But prior to this version, there was no easy way to make an exception. So it was very easy to say, okay, I want this check to run on all my big mem nodes. What you couldn't do was say, I want this check to run on everything but my big mem nodes. In other words, you couldn't negate a match string. Well, now you can. And it doesn't just work in the configuration file. Any place that accepts a match string, you can now negate it. So there are a number of checks that take match strings as parameters, and they support this as well. A new check was contributed by John Hanks, a user at Caos. I enhanced it to take several of the more useful options to the ping command, so you can now check for connectivity with your master node, another server, whatever it is you might choose. So there's a check for ping. For all of the different process checks that we have, and there's a whole list of them that you'll see here in a little bit, all of the owner check parameters will now take full match strings. So you can match on regular expressions, ranges, and external matches for owner check. So it's not just a static string anymore. For check PS service, one of the users requested that we not just kick off service restarts and service cycles and such in the background. Previously, if you needed to restart a service, it would do service, whatever, restart, but it would background it and go on about its merry way and just hope for the best. It'll still do that by default, but now there are flags that you can specify. Lowercase v will run it in the foreground and make sure that it works, and if it works, the check will pass. So if it finds that SSHD is not running and you have told it to start it, it'll start it, wait, and if that start command returns success, it'll go on and the check will pass and everything's fine. The capital V, I know those two V's don't look very different, but I promise that's a capital V. The capital V for verified check, after it does everything that the lowercase v does, it will then go back and verify that what was supposed to happen actually happened. So if you tell it to kill a process, it'll actually go back and make sure that that process is honest to goodness really dead. So there's an additional verification step that takes place. Mike Dubman from Mellanox requested that we be able to look at the output of dmessage and look for, in his particular case, InfiniBand system call backtraces. He was using that to flag when the kernel module, the InfiniBand kernel module, might be misbehaving. So there's now a check command dmessage where you can do match strings against the output of the dmessage command. In order to make that happen, I went back and I refactored an existing check called check command output, which is basically the same thing but for an arbitrary system command. So you can match against the output of any command you want. So now it's entirely possible for you as a user to create a check of your own invention that wraps check command output, so you can customize error messages for a given command that you might want to look at. Like if you want to keep an eye on your mail queue and have certain error messages pop up if your mail queue is starting to get full. You can write your own wrapper to check command output, customize your match strings and customize your error messages, and now the dmessage check is a commented and thorough example of how exactly to do that. So it makes it a lot easier. There's a new command line flag to run a single check and then exit. So if you have a check that you want to test, you don't have to rewrite your config file or write a new config file just to test that one check. You can have NHC just execute that single check and then return. And remember, a check is really just a line of shell code, so you can do that with any arbitrary shell code that you want. And just a little minor tweak, checkfs mount will now create mount points if they're missing. So if you say you want it to check for a mount point of global scratch and for whatever reason there is no directory global scratch, it'll create it for you. You'd think that would never be a problem, but you'd be wrong. There were also a number of fixes and enhancements that took place. I won't go through all of these in the interest of time. Let's see. There was one in particular. Oh yeah, the one on the bottom, I have Killian to thank for that, so thanks Killian. The big thing that is of interest is the range checking. If you can do node range matching in your config file for matching a range of nodes. The way that used to work, it was contributed by a user, and I guess I was sleeping the day I imported that patch, but it would actually iterate through the entire range that was specified and then compare every single number in between with the current node name to see if it matched the range. If you had a large range, that could take a significant amount of time. So I rewrote that so that it would just do a numeric comparison, which saves quite a bit. And there was also a bug that a couple of bugs you might have run into. If you had a node range that had leading zeros, it was possible either for that number to be interpreted as octal and miss some nodes in the range, which if that happens, you might not even know that it's happening, or it could return a weird looking error, bash complaining that something is not valid for octal. So at least if that happens, you know about it, but it's possible for nodes to get missed. That's fixed now. There's also potential for rounding error. If you had 1.5 terabytes of RAM, it would truncate it because bash doesn't support floating point, so it truncate to 1 terabyte of RAM, which is obviously a pretty big error. So now it detects that and will go back in order of magnitude and express it in gigabytes instead. One of the recent features that is incredibly useful but might not be intuitively obvious just from what's in the changelog, so I wanted to make up a slide on it to illustrate how it can be used. It was a direct result of a conversation with Killian from Stanford. They use cluster shell and wanted to be able to use some of the cluster shell grouping syntax to do node matching for their NHC config file. So rather than come up with something that was specific to cluster shell, I thought, well, I'd love to be able to do that for Warewulf groups and Warewulf clusters. I'm sure there is somebody somewhere who's still using NIS who might want to be able to match against node groups. And I could think of any number of possible external commands, and rather than trying to come up with that many individual delimiters for matching expressions, this is what I came up with instead. So you can specify any arbitrary delimiter character you want, or pair of delimiter characters. And you can specify any arbitrary subcommand that it'll run to determine if the current string matches. So, for example, here, my first one, I'm using a % sign. This one, I'm using an @ sign. Here, I'm using the less than and greater than signs. And here, I'm using tildes. Now, when it does the parsing, the first delimiter character is the first character in this string, and the trailing delimiter is the last character in the string. So it doesn't matter what's in between, and it doesn't matter if they're the same. All it cares about is first character and last character. So, for example, here, the less than, greater than signs, that corresponds to this command here, which will basically print out any groups in Warewulf that correspond to this name. And the %m comes from whatever you have inside here, inside the delimiter characters. And then the %h is whatever the value is. So for matching in a config file, the value is the host name of the node. If you're matching against an owner of a process, that value is the actual owner of that process, like root or daemon or bin. So hopefully those examples will be educational. You can kind of get a feel for how that works. If you're careful about how you do it, you can use regular expressions or any number of creative ways of doing matching. It's all entirely up to you how you use it, and you can use any external commands you want. One thing to keep in mind, as it stands right now, when NHC does these substitutions, it adds double quotes around them. I'm probably going to change that because it's turned out to be more of a pain in the ass than I intended, but for now, keep that in mind. that make sense? Any questions on that before I move on? I know that's a bit heavy. All right, future editions. You'll notice I specifically avoid use of the term roadmap. NHC is one of about a bajillion projects that I'm involved in. I'm currently working on a Docker-based wrapper for generating and managing host images under revision control. I'm currently working on a jellyfish-like container-based cybersecurity intrusion detection and prevention system, and several other projects. So to be able to put dates and milestones and such on NHC would be picking numbers and stuff out of the air, and I don't like to do that. So basically I just have a list of ideas and I try to do them as I can or as users contribute. But here's my list of ideas as it stands right now. As always, user contributions are welcome. If you want to know what's in the queue, we've already got an NVIDIA SMI check that's sitting there waiting for me to accept. There's also one that's been submitted for doing rolling reboots, which happens to be on my list, so yay. I'm looking to do some Slurm diagnostics. I already have some for Moab and Torque, but I'd like to add some for Slurm as well, and some more for Moab and Torque. There's a lot that I could do doing something with the LSOF command, so I'd like to write a check for that. I'd like to add a minimum CPU time feature. Right now we have a couple of checks that are specifically designed to look for rogue processes on a system, either based on not appearing in a list of authorized users or because they can't trace their lineage back up to the Slurm or Torque job daemon. So if either of those happens to be the case, it can flag processes as being rogue on your nodes and kill them off. This is useful for cleanup purposes. It's also useful if you have naughty users who like to SSH directly to nodes and run jobs and try to circumvent your allocation system. But I would like to make them more robust and or combine them into a single check with some command line options for combining the functionality and making it easier to use and so forth. A lot of the checks in NHC that spawn subcommands, like anything that deals with processes, you have to get process data. So it has to run the PS command at least once. But the way it does it, it runs the PS command once, and it gets all the information for all the processes on the system and stores it all in a series of parallel bash arrays. And then once you take the hit once, you don't have to worry about it again. You can have as many process checks as you want. It'll just use the existing data. You don't have to run a PS pipe grep this, that, and the other thing every single time you want to look at processes. And there are a lot of checks that do that. So there's a series of data caches in there that hold all that information. In the case of SGE, though, running as a load sensor, NHC will actually continue running for a long period of time. So I'm planning on adding some timeouts to the data cache. This would also permit NHC, I know it sounds pathological, but you could load NHC into an interactive bash shell and actually run it interactively, doing checks from the command line and so forth. Everything inside of NHC is a bash function, including almost all of NHC itself. The reason I did that is so that I could do unit tests for everything. Well, it has the side effect of I can do a .NHC and basically load the entirety of my Node Health Check system into a shell. And there's all kinds of weird, funky, crazy stuff you could do with that. But it requires some additional engineering. And as if that weren't crazy enough, I'm contemplating writing a C-based NHC daemon process that will load and store and provide a file-based interface to certain system data. Bash is very, very good at reading from files, and you don't have to shell out to something else in order to read files into Bash itself. So anything that it can pull from an existing file on the system saves me a shell out. So if I can write something that can provide file-based access to anything and everything I need, I can reduce even further the number of subprograms I have to spawn. So I'm out of time, but I have lots more slides in this deck. So if you download a copy, you'll have all kinds of references for lots of different checks. Config file syntax and all sorts of stuff. Yes?
Could you compare and contrast NHC to something like a configuration management tool?
Are you thinking along the lines of Puppet? Okay. So Puppet and similar tools are written on the principle of defining the way you want the system to be and taking the steps necessary to idempotently bring it into compliance with the definition of correct that you've set. NHC, on the other hand, is intended to look for discrepancies not in how the system is built and configured, but more in how the pieces are talking to each other and interoperating with each other. So there are some similarities, at least in terms of Puppet going out and comparing known good with current, but the goals are very different. Puppet is trying to figure out what steps it needs to take to bring the system into compliance, whereas NHC is just looking for the discrepancies themselves. So this was kind of a result of a conversation that happened this morning. Steve Jones and one of the guys from the Naval Postgraduate School were chatting and said, gosh, I saw an awful lot of slides there at the end that got skipped. I wish I could have heard more. And since we had some speakers who couldn't make it, I said, you know, I'm more than happy to finish if you really do want to hear more. I don't have anything particular planned, so I mean, I can go ahead and walk through the rest of the slides. I can take questions. I'm pretty flexible. If I don't hear anything in particular, I'll just kind of start going through the rest of the slides. All right, so as I said, there are 45 different checks at last count that are built in. They're installed by default into etc NHC scripts, and any of the files in that directory that end in .nhc will get loaded automatically. So if you have your own set of checks that you want to add to NHC, it's really simple. All you do is drop a file, something.nhc in that directory, and it'll be automatically loaded and you can use them. I talked about the first two checks on the list yesterday. The third one simply looks at the return code of a command. It doesn't care what the output is. It actually throws away the output. So if you've got something that generates a lot of output and you don't care what it is, you just care about success or failure, then you can use the check command status. The check command output will actually gather up all of the output into a big bash variable. So if you have something that does generate quite a bit of output, you have to be cognizant of that. There are two DMI checks. DMI is something we didn't talk at all about yesterday. If you have particular BIOS versions on your nodes that you require, or if there are particular BIOS versions that cause problems for your system. We've had situations where there were bugs in BIOSes in a particular version, and we wanted to make sure we didn't have any nodes running those versions. You can do checks against your DMI data. There's a command that comes with most Linux distributions called DMI decode, and it breaks down the contents of your DMI data into sections with handles. And so you can supply the handle and type of the information you're looking for, and then a match string to match against. And that can be positive or negative. So you can say, I'm looking for this string, and if I don't find it, that's a problem. You can also say, I want to make sure this string doesn't show up, and if it does show up, that's a problem. So either of those senses will function correctly. There's also a raw data match. If you don't know what section the information is going to show up in, and you just want to do a raw match against the entire set of DMI data, you can do that as well. We've got checks for file contents. If you have a configuration file, you want to make sure it has particular values in it. Or if you want to check your password file, make sure that certain accounts are present. You can match against the contents of any file. The check will only take one file name at a time. So if you want to check multiple files, you need multiple instances of that check. But each file can support any number of matches. So you can match any number of items inside of a single file, and each individual match string can be positive or negative. So you can look for something that's there or for something that's better not be there. We also provide wrappers for the stat command and the test command. Test is a shell built-in, and it looks at a lot of different attributes of a file. If it's a block special, character special, if it's writable, if it's readable. And anything that you can do with Bash's built-in test command is going to be a lot faster because it doesn't have to shell out to anything. But there are limitations to what you can do with test. So we also provide a wrapper for the stat command. Stat will look at all of the different file names that you've specified there at the end of the command line, and it will launch a stat command for all of those files. And it stores all of that stat data into a cache. And for all of the different checks that you have, it'll go back and look at the cache data, compare it to what you've specified you want to look for, and then detect any issues that might be there. If you have multiple commands or multiple instances of a stat check on the same file, it'll use the same cache data. So you only have to run stat once. We have a wide array of file system checks. The first one specifically looks for mount points being present. You can match on where the file system is mounted from, so you can make sure it's coming from the correct file server. If you've decommissioned an old server, or you have multiple servers that you need to round robin among, you can check for that. That's what source means. You can also look at various options, so you can do matches against any of the mount options. This is handy for doing NFSv3 versus NFSv4. If you're not in an environment where you support NFSv4 identities, if you don't have IDMapD running and don't want to get all that set up, you want to make sure that your file systems are mounted with NFSv3. So you can use NHC to check for the vers equals 3 option on your mount line, and if it's not there, it can alert you. The latest version of the checkfs mount command is also capable of not only detecting problems, but actually fixing them. If you've got a file system that's supposed to be mounted and it's not, it can actually go and mount it for you if you tell it to. And you can supply the options that you want it to mount with. Now, this is not a requirement. You can just check and report if you choose to. But one of the more recent additions to NHC by request of the guys at NERSC was don't just find the problems, but actually do stuff to fix them. So being able to mount file systems that are missing is one of those things that we can fix. We also, as I said yesterday, fix missing mount points. Just to make things easier, if you specifically want to look for file systems mounted read-only or mounted read-write, there are a couple of shortcuts. Mount RO and Mount RW take all of the same options as checkfs mount. They basically call checkfs mount and pass an additional check for mount options to make sure they're mounted read-only or read-write as specified. This is particularly useful if you have a local disk. If it goes bad, Linux kernel by default will remount that file system as read-only. This happens a lot with /temp, and if users can't write to temp, a lot of times their jobs will fail. So this will catch that before your users do. There are also checks for file system size and file system utilization. You can specify sizes with suffixes like M and G and T and K and so forth to make it easier, or you can specify a raw byte number. There's also the used and free checks, as well as looking at the total size. And you can check for inodes in addition to regular space. So you can check for free inodes. If you deal with a lot of bio customers, bio file systems are notorious for having massive quantities of very small files, and you can very easily run out of inodes. So this is handy for making sure that you have at least some minimum amount of inodes free. And if you don't, then you definitely need to go and add more. There's also quite a few hardware checks. We look for CPU configuration, number of sockets, number of cores, and number of threads. If you are particular about whether or not you have hyperthreading turned off or turned on, having the cores and threads numbers the same or different will determine whether or not hyperthreading is off or on. So we use that to detect nodes that have come in and were not set up properly to turn off hyperthreading. We can look for Ethernet devices, MirrorNet devices, and InfiniBand devices. And we can verify on the InfiniBand devices that they're connected at the appropriate rate. So that would be, for example, 40 for QDR or 20 for DDR. If it's up and ready to go but not at the correct rate, it will give you a warning to that effect. We can look at memory, either total memory or free memory, in terms of overall memory or physical memory or swap or any combination of those. You'll notice that there's a fudge factor at the end there for each. Linux is notorious for using some sort of pseudo-random algorithm to report the amount of RAM that you have in your system. I still haven't figured it out, and I don't know anybody else who has either. But that number fluctuates for reasons unknown. So there is a percentage fudge factor that you can add so that if it's within like 3%, it's all good. But if you've lost a DIMM, obviously that number is going to go down way more than 3%. And that's really what we're looking for with these checks is, have I lost a DIMM? Is there a memory module that's gone AWOL? Or has my swap file or my swap partition not been activated properly? So those things will get picked up. There is also an MCE log check. If you've had machine check exceptions, it can look for those. It's not documented here on the slide, but there are a couple of variables that you need to look at for the corrected and uncorrected error limits if you're going to use that check. But it's documented in the GitHub docs. If you use Moab and Torque, we can look for versions and status of the scheduler and resource manager for both of those products. If there's an alert status in Moab, or if your Moab and Torque aren't talking to each other, NHC can detect and report that for you. For networking checks, we can do pings, as I mentioned yesterday, but we can also look at sockets. So you can detect and see if there is a listening socket open on port 22, for example, and that would be a positive assertion. You may also want to have a negative assertion for things like a web server. If there's a web server running on your compute nodes, you may have a problem. So these socket checks can be positive or negative. And you can check any of the logical attributes that you might be interested in for a socket. And if there are two parameters for actions to be taken, the lowercase e is action if the socket is not there, and capital E is the action to be taken if the socket is there. So you can use that to restart a service if you're looking for SSHD or whatever the case may be. There is a utility that comes with the NVIDIA development kit called HealthMon that looks at the health and status of all of your NVIDIA GPUs. We essentially wrap that command, and if there's something that it comes back with as being a problem with your GPUs, it will provide you whatever the feedback was from the HealthMon command. So it'll basically dump the entire output for you. So we don't just use NHC on our compute nodes, we also use it on our interactive nodes. A lot of times we'll have users who are new to the concept of HPC and don't really know what they're doing. And those users are notorious for launching jobs and heavy processes right there on the interactive nodes. So we use NHC to patrol our interactive nodes and make sure that users aren't doing things that they shouldn't, like running ANSYS or other computational jobs right there on the interactive nodes. So we've got 4 resource checks that we can look at. We can look at CPU consumption, memory, physical memory, which is strictly RAM, as well as CPU time. And you can take actions. You can log with -L, you can syslog with -S, you can kill the process, which is lowercase k. A recent addition, the capital K, instead of killing the process or in addition to killing the process, the capital K will terminate the parent process. This is particularly useful if you want to detect MPI jobs. So not only do you terminate the MPI job itself, but you can also terminate the ORTED process that launched it. So if you use OpenMPI, the parent process of your MPI jobs is going to be an ORTE daemon that OpenMPI supplies. So you can terminate both the job and the parent process with that. Yes?
Quick practical question. How do you solve like real application launching from file separation, let's say tar or bzip? Because you do a max-to-mem ratio, or because like the way we do it right now is usually with filter through the type of preparation, allowing only a few of them, like tar, bz, offing, and so on. If I do that, then I'm gonna get a warning if the file separation is compute intensive.
So you can do negative assertions against the name of the command or the full command line. So if you use the -F, that matches against the entire argument list. Without the -F, it's just the argv sub 0. But if you do like -m, bang, tar pipe, gzip pipe, bzip2, etc., you can whitelist some quantity of commands so that they will not be terminated. Generally, what I do is, over time, I've built up a list of processes that are problematic, that I see people tending to run. And then I have positive matches on those. Rather than excluding the ones I want to allow, I go after the ones that I know about. I would rather have somebody get away with shenanigans for a little while before I catch them versus terminating a legitimate process on the interactive nodes. Different sites may have different requirements or different preferences. That's okay. That's why there's sufficient customizability. But you can do either the positive assertions or the negative assertions, and they both work. We also have process checks for doing general system monitoring. So in addition to nodes, we also use NHC to monitor our servers. This includes web servers, data transfer nodes, file servers, and so forth. So we have a number of checks for looking at processes and services that should be running on the node. The two older checks that we supported were check PS daemon and check PS blacklist. Those are positive and negative respectively. So check PS daemon says this guy should be running. If it's not, I need to know about it. Check PS blacklist is this guy should not be running. If it is, I need to know about it. Both of those have essentially been obsoleted by check PS service. I was having a chat with one of the guys from NERSC one day, and this is where the request to fix the problems, not just find the problems, came from. And I couldn't really figure out how to work his request into those two checks that I already had. So I came up with check PS service and completely rethought the whole thing from scratch. And so those two older checks are kind of obsoleted. Check PS service can do either positive or negative matches against process names, owners, etc. There are 5 primary actions you can take. The capital S is a start, so it won't restart, it'll just start. In most cases, if you run service whatever restart and it's not running, it'll do the right thing, it'll just start it. However, there is a notable exception, and that exception happens to be SSHD. Probably the most important service that you could possibly be checking on all of your nodes, because if you can't SSH in, you're basically to the point of having to reboot or go to the data center and plug in a console. If you do service SSHD restart and SSHD is not running, the main listening SSHD is not running, but you have a bunch of user sessions SSHDs that are still running, they will all be killed. If SSHD, the main listener process, is running and you do a restart, it will restart and all of your user sessions will be fine. But if it doesn't start up successfully, or if it happens to not be running for whatever reason, and you do a restart, all of your users will get kicked off and they will be most unhappy. So the -S is important for that reason, so that we can specifically do a start rather than a restart. -r obviously is restart. -s is cycle, and -k is kill. Or sorry, S is stop, K is kill. The lowercase c is cycle, which essentially means do the stop and then sleep for a little bit and then do a start. That's useful for things like MySQL and so forth that have a history of not really stopping when they say they're stopped. So that gives them a little bit of time to regroup before you kick them back off again. So you can specify the daemon process name. If you don't specify the daemon process name, like SSHD, it will default to whatever you give it for the service name. So the service is whatever is going to come at the end of the command line when it does service something start or stop or restart or whatever it happens to be. So the service name has to match up with whatever systemd or etcinit.d are looking for. If that does not happen to match the name of the process that NHC needs to look for in the process listing, then you either need to give it -d daemon for just the daemon process name, or if you need to do something more complicated like match against the entire command line or match against the name of a Python script or whatever it happens to be, you can use a full match string with -m instead. And yesterday I went over the capital V and lowercase v, so I won't go over those again. The two E actions I think I already went over as well. -0, 0 means non-fatal. So you can have a check that will perform whatever actions you tell it to perform, but even if something goes wrong, or even if the service happens to not be running, NHC will let you know. It'll print a message, but then it will continue running. It'll continue on with any other checks that you might have. By default, if NHC encounters an issue, if something fails, it will stop right there and exit. That way you get the reporting back as quickly as possible. Yesterday I mentioned two procedures for cleaning up nodes. Check PS unauth users and user proc lineage. Those look for unauthorized users based on the owners of the job scripts, or user proc lineage traces back each process on the system to make sure it's each user process to make sure it has parentage from either Slurm or PBS or whatever your resource manager daemon happens to be. And any processes that aren't authorized by one of those two methods, you can tell it to log them, you can tell it to kill them, etc., etc. So in the slides, I basically have a 5-minute quick start. It takes 5 minutes or less to get going with NHC. You basically just have to download and install the RPM, get yourself a config file, and then figure out how you're going to launch it and set it up. So it's pretty straightforward. This is a walkthrough with commands of exactly how you would do that. This one downloads the source from GitHub and then does a build in the tree, installs the RPM. Now for the configuration, what I recommend to people is that you start off by running NHC GenConf on one of your nodes. If you have a bunch of heterogeneous nodes, then you may need to run it more than once on each of the different ones. But you run NHC GenConf and that will generate an automated configuration file for you. Then I would take that auto-generated config and I would merge it into the sample configuration that gets installed with NHC. Between those two, that gives you a really good head start on getting it customized. From there, tips on the mailing list, things you might read online, etc. Or just stuff from reading the documentation. There's a lot more that NHC can do than I could possibly put in any number of sample configs, but this will at least get you going. Then once you have a working config, you just run NHC, and assuming it returns success, you're good to go. Then once you have it working, all you have to do is configure it to work with whatever resource manager you want to use, or if you're going to use it standalone, then you set it up to run some other way. It can run under cron. Generally, that's the preferred way if you're not going to run it under a resource manager. And I like to use the NHC wrapper that comes with it because it allows me to run NHC at a high frequency interval without having it email me every 5 minutes if there's something wrong. Basically, NHC wrapper will take the results and save them, and if the results from this run match the results from the last run, I won't get an email. So there's information for configuring Torque and Slurm as well. And then that's it. This is also a pretty solid example configuration, so you can pull ideas from here as well. I don't have time to go through every single line of this, but I've gone through most of these checks already, so a lot of it would be repeat. One thing I should point out, this is an example of a configuration you might want to run in-band, meaning under a resource manager. With NHC, you can run separate contexts. So you pass it the -n parameter and some name, and you can run different contexts, which means a different configuration file. This is useful if you want to run certain checks under a resource manager that are job related, things that might cause a job to fail, but you also want to do general system monitoring outside of the resource manager for things like file systems getting full and so forth. So this configuration is the checks you would potentially want to run hourly outside of a resource manager, and then you can run the previous slide checks like at a 5-minute interval under the resource manager. So you'll see that there's a lot more going on in this config file than there was on the last one. It's not the case with Slurm, but it is the case with Torque, that health check scripts are run single-threaded. So if you have a health check script that hangs or takes a long time to run, PBS Mom will sit there and block, and it won't do anything until your health check finishes. That's why NHC goes to pathological lengths to finish quickly, to make sure that it doesn't hang up PBS Mom any more than absolutely necessary. And that's why you might want to run some of the more resource-intensive checks outside of Torque or your resource manager. All right, these we've already gone over. But I did want to draw some attention to a couple features that are unique to NHC that I didn't have a chance to talk about yesterday. Okay, here we'll talk about NHC wrapper first. So NHC wrapper allows you to specify an email subject, a mail to address, as well as a time specification. So I mentioned that it saves the results of the previous run and does a comparison. If they match, it won't send an email. But if you specify the capital X and some amount of time, after that amount of time, like 6 hours, it will expire the old results, whatever they were. It'll delete the old results. And whatever the results of the current run, it considers them fresh. So the end result is, if you want to expire them every 6 hours, then you'll get a new email every 6 hours as long as there's a problem. That allows you to run NHC every few minutes or so, but it won't harass the tar out of you. But you don't want to forget, so it will remind you at some interval of your choosing. The other thing you can do with NHC wrapper is you can run it in a terminal in a loop. You can tell it to loop every 5 minutes, or every 2 hours, or every 6 hours, or every 3 hours, whatever you tell it. And it will actually figure out what the next round number of that interval is. So if you say every 5 minutes, it won't just run and then sleep for 5 minutes. It'll figure out what every 5 minutes means, and it will run itself on the 5-minute blocks, 5 after, 10 after, 15 after, 20 after, and so forth. Same with hours. If you say run every 3 hours and you run it at 2:35, it will run itself again at 3, and then again at 6, and then again at 9, and so forth. So it's very intelligent looping.